In this chapter, we're going to talk about water and the hydrologic cycle, the distribution of water on Earth, freshwater ecosystems, how we use our freshwater systems and how we're altering them, and also problems about water supply and some solutions. So when it comes to fresh water, one thing to keep in mind is that fresh water is a limited resource and we are using it faster than it can be replaced. So does this mean that fresh water is a renewable or a non-renewable resource? Well, if you chose non-renewable, you would be correct. Remember, resources whose supply is finite or resources which we are using faster than we are replenishing are considered non-renewable. So water might seem to be pretty abundant, but actually drinkable water, fresh water, is pretty rare. 75% of the earth is covered with water. So how can it be rare? Well, if we look over on the left-hand side of the slide, over here, you'll see that this is showing all the water on Earth, and 97.5% of it is salt water found in the oceans. Only 2.5% of Earth's water is fresh water. Now, what do we mean by fresh water? Well, fresh water is relatively pure and has very few dissolved salts. Now, if we look at the fresh water that exists on Earth, this 2.5%, and we look more closely at that, we expand it over here, you can see that most of fresh water is actually bound up in ice caps and glaciers, 79%. Of course, that's changing with climate change. About 20% of fresh water is in the ground in the form of groundwater, and 1% is on the surface, which is, well, let's see what the surface is. If we look over here, surface water, most surface water is found in lakes, 52%. Then some of that water exists between soil particles as moisture. Some is atmospheric water vapor. And then 1% is found in living organisms, and about 1% is found in rivers. So if we just look at lakes, for example, fresh water found in lakes, which is where actually most big cities get their drinking water, from lakes, remember that this is 52% of 1% of 2.5%. So that's something like 0.01% of all the water in the world is found in lakes. And that's what most big cities are using for their drinking water source. So you might get the idea that there's not a lot of available fresh water on Earth. Well, this image shows you where most of the fresh water is found in the world. So if we look at the upper left-hand corner, this purple area, it shows you where glaciers and the permanent ice caps are found. So this is where the fresh water can be found in glaciers. And if you look over here, it shows you that the size of the bubble relates to how much water there is. So the bigger the bubble, the more water. So again, if we're looking at glaciers and ice caps, which remember is where most of the fresh water in the world is found, you can see that Antarctica, or the South Pole, has the greatest amount of fresh water. And the units here, by the way, are cubic kilometers. You'll also notice that Greenland has got the second greatest amount of water in glaciers and ice caps. And that is then followed by North America. Now, if you'd like to know where most of the water is in the ground, we can look at the brown area. And again, it's in cubic kilometers. So you'll see that most of the water in the ground is found in Asia. And that's followed very closely by Africa. A lot of times people think of Africa as a desert, but actually Africa contains quite a bit of water, in this case in the ground. If we want to know about where is the fresh water found in wetlands, large lakes and reservoirs and rivers, we'll look at the green area. And you can see that the number one place for fresh water is in Africa in terms of rivers and lakes and other surface water bodies. So again, Africa isn't, parts of it are desert, certainly the northern part, but the rest of Africa has quite a bit of water. So the amount of water in our ecosystems is finite. And to get a better understanding of the water we have, it helps to know how it moves through the environment. And that is what the water cycle is. It's the movement of water through the environment. So what are the major sources of water? Well, we've already said there's plenty of water found in oceans. And then if we want to consider salt water, we've got, fresh water, we have glaciers and ice caps. We have groundwater, and then lakes, rivers, streams, etc. So how does this water move from one area to the other? Because the water really just cycles over and over through our environment. Well, one way water moves is from aquatic and land systems to the air, and this is called evaporation. Okay, so evaporation is the movement of a liquid water, to the air in the form of a gas, evaporation. Now, plants and trees also release water vapor from their surfaces. This is called transpiration. Condensation is the conversion of water from a gaseous state, such as water vapor, to a liquid state, condensation. So water is changing from a gaseous to a liquid state. And lastly, precipitation is condensation of water vapor as rain or gas. So now we're moving from a gas to a liquid. And these are the processes by which water moves through our environment. Now, water falling back to Earth is not readily available to most of our planet's population. So here we have the water cycle. And if we start here, we can start with the sun and solar energy. So the heat from the sun warms up the water on the surface in the oceans and causes it to evaporate. So it's changing from a liquid to a gas. And also you can notice that the water that's on the surface of the land is evaporating. Also, the plants are releasing water vapor from their surfaces, from the surfaces of leaves, and that's evaporating. Now, once this water gets into the atmosphere, it condenses. And what happens, first of all, is it cools. Condense means that the particles become closer together and it becomes denser, and then eventually it is going to fall back down to Earth as precipitation. And that could be rain, snow, or ice. Once it falls back onto land, it could be on the land, it could be on the oceans, but if it does fall off on the land, it eventually runs into rivers and streams, which eventually flow back to the ocean. In addition, some of the water can trickle into the ground and can stay in the ground as groundwater. This groundwater does eventually move towards a river if one is nearby, or towards the ocean. So this is how water just moves over and over again within our environment. We don't lose it. It just cycles over and over. So water scarcity is a global issue, and it is reaching a crisis in the world today. Most of the nations of the world get their drinking water from surface water sources like a lake or a river. So we're going to take a look at a problem. This is a more local problem in the U.S. with a surface water source, which is the Colorado River. The Colorado River starts in the Rocky Mountains and then flows 1,400 miles to the Gulf of Mexico. There are 53 dams along the rivers and its tributaries. So what is the purpose of dams? Why do people have dams? Well, they have a lot of purposes. One is to control floods. Another thing that dams do is you can store water in them and you can use them to irrigate crops. In fact, 7% of all U.S. crops are irrigated by the Colorado River. Dams can also be used to create ponds and lakes, which then supply drinking water. In fact, the Colorado River is the source of drinking water for 30 million people. Dams are also used for recreation because you can create a lake that people can swim in, and of course for electricity. So the Colorado River flows through many states, and Nevada is one of them. Nevada is a rapidly growing state, and they need more water. So, a little bit of background on the Colorado River. So you can see from the picture on the right that the Colorado River starts up here somewhere in Colorado in the Rockies, and it flows 1,400 miles to the Bay of California. Now it does go through Mexico. There's a very little stretch right here that goes through Mexico. So the states with rights to the Colorado River are divided into an upper and lower basin. The upper basin consists of Utah, Wyoming, Colorado, and New Mexico. These are considered the upper basin. The lower basin states are California, Nevada, and Arizona. Now remember, a watershed is all the land that drains into a water body, in this case a river. So just as a reminder, a watershed is the area of land drained, in this case by a river. So you can see that this dark green area around is the watershed of the Colorado River. And you can see little tributaries and rivers that eventually drain into the Colorado. So in 1922, 7 of the states along the Colorado River entered into an agreement that each state would get 7.5 million acre-feet per year. And they called this the Colorado Compact. So they said each state would get 7.5 million acre-feet of water per year. They call this the Colorado River Compact, or the Law of the River. Because if they shared it all, then the people at the end of the river, before it drained into the ocean, would still have water left at the end. Since that time, numerous treaties, agreements, court decisions have divided these waters even further between the 7 states and the American Indian tribes and Mexico. So by 1931, people had begun to build dams on the river. And of course, the purpose of the dams was to pool the water up in certain areas. Here's one, Lake Powell. There's a dam there. Here's another, Lake Mead. To pool the water so that people could use it for drinking water, for recreation, and things like that. As time went by, some of these towns and cities grew, and certainly Las Vegas, which is in Nevada, really started to grow. Now, Las Vegas is technically in a desert, but if you've ever been there, there's lots of greenery, golf courses, and things like that. So as they grew, they needed more water from the Colorado River. But the other states didn't want to allow them to do that. So that would have been renegotiating the Colorado Compact. So instead, what the people of Las Vegas said is, well, if you don't let us use water from the river, we are going to go to the Great Basin, and we're going to put wells into the ground and pump water out of the Great Basin. Now, the Great Basin is an environmentally sensitive area, and by pumping groundwater, you could affect it adversely. But the states that were in the Colorado Compact would rather that happen than Las Vegas take more water out of the river. So that's what happened. And you can really start to see from this how desperate states can get for access to water, and how this is a real problem in the western part of the country. So as I mentioned, by the 1930s, people had started to build dams, and one of the most famous ones is the Hoover Dam. And this was built in the 1920s, actually. And you can see to the left here is a picture of Black Canyon, and this is where the Hoover Dam was built. And this is what it looked like before it was built. So this picture over here is a view from the top of the Hoover Dam. It is a huge, huge dam. It contains a tremendous amount of concrete. In fact, if you took all the concrete in the Hoover Dam, you could pave a highway from San Francisco to New York City. It's really large. This is a view from the bottom of the dam, and you can see the Colorado River moving along. Now, this dam created a lake called Lake Mead. I visited this dam in 2013 with my family in July when the air temperature was 110 degrees Fahrenheit. It was incredibly hot. But the water temperature of the river was 50 degrees, which is incredibly cold, which is really interesting. So this is Lake Mead. This is the lake that's created by the Colorado River. And again, the purpose of creating this lake was for recreation, for flood control, to control sediment, coming off the land during heavy rains. It's used as a drinking water supply. It was used to irrigate crops, hydroelectric power. This lake supplied about 23% of the power to Nevada, 28% of power to Southern California, and about 18.9% of the power used by Arizona. So as you can see in the picture, the Lake Mead is vanishing. Here is a platform that people would walk out on to look over the water, and you can see the water. There's no water there. In the lower picture, you can see the water line, the top of this white area. This is where the water used to be, and you can see how much it's dropped. Now, the reason the water is disappearing is, one, because of a severe drought in the Midwest and the West, which has been going on for quite a while, and that's due to global warming. The other reason is that as the population in this area increased, specifically in Las Vegas, there was an increased need for water. So they just pumped more water out of the lake. So back to the Colorado River. So remember, it begins in the Rockies, it ends in the California Bay, but it does have to go through Mexico. So by the time the Colorado River reaches Mexico, about 90% of its flow is gone. Mexico then diverts the remaining 10% of water to a canal for farming in the county of Mexicalia. So actually no water reaches the ocean. So what you're seeing in the upper right-hand corner is the Colorado River Delta. Now, a delta is an area at the mouth of a river where silt and other materials deposit. So again, it's an area at the mouth of a river where silt, oops, I'm going to have to write it over here, and sediment deposit. Okay, so I'm going to just continue that over here. So you can see the river kind of comes along here, and then what you're seeing really is deposits of sediment and silt, and this can build up. It can form tiny streams and wetlands, and these wetlands are often very rich and fertile, and this is what happens at the ends of a lot of rivers. You can see below here is the Morales Dam, which is at the end of the Colorado River, and you can see it's pretty dry. So there is no, the water usually is coming over the wall like this, so it's pretty low. So again, by the time the Colorado River got to the end of to the California Bay, it was pretty much dry. So this was a big problem. And in 2012, there was a historic agreement between Mexico and the U.S. They called it the Minute 319. This was a 5-year pilot, and in this pilot, the U.S. and Mexico were going to provide about 195 million cubic meters of water to the Colorado River in Mexico, which is about 1% of its yearly flow. So what that means is the U.S. and Mexico would be adding water to the river. And that was so the river would actually make it to the ocean. Now, in order to do this, they had to buy water rights from farmers who were along this river. So they had to say, please don't farm, please don't use the water. Instead, we will buy the water rights, and that meant the water would continue to flow through the river, so they wouldn't be taking the water out of the river. And they formed what's called a water bank. Now, if successful, this effort could be extended to 2026. So what I'd like you to do is watch this video. If you click on this link below, there's a video on this minute 319. And what I would like you to answer is, what percent of farmland in Mexicalia would have to sell their water rights in order to meet the restoration goals of the Delta Water Trust? So in order to meet the goal of this water bank, the water trust, so that there would be enough water added back to the river to make it to the ocean, what percent of Mexicala farmland would have to sell the water rights? What percent? So that's what I would like you to answer after you watch the video. Okay, so most of the water on Earth is in the ocean, but most of the fresh water we use is on the land. So where are some of the places on land that we find water? Well, the water rains in the mountains or snows in the mountains, and then it forms a river. And at the beginning of the river, which is called the headwaters, the water is usually very cold and very clear. There's very little sediment in it, and it has very few minerals. Usually the water is flowing through a very narrow channel and with a very rocky bottom to it, and it flows very swiftly. So when hikers come upon these waters, it looks cold, clear, crisp, and clean, and they want to drink it. Should you drink this water? Well, if you answered no, you would be correct, because even though the water is in a fairly pristine environment, there are always pathogens around. Giardia lamblia is a protozoan parasite. You can see the picture of it here. Here's one organism. And these organisms can live in the environment in cysts for a very long time, and they can resist cold temperature. They're usually found in the digestive tract of animals, and when animals defecate and it falls into the river, or if they die and fall into the river, these organisms will survive in the form of cysts. So if you come along and drink it, they will then colonize your intestines, and that's where these Giardia are, and they cause severe diarrhea. So don't drink the water even if it looks clear. So water can be found in rivers which start in mountains, and as they flow downstream, they collect more water from rain. Snow melts and flows into the river. Springs add to it, and pretty soon the river gets larger and larger. And by the time it's almost into the ocean, it's slowed down considerably. Where a river enters the ocean is called the mouth of the river. So near the mouth of the river, the water at this point is moving more slowly. High turbidity, that means there are a lot of particles dissolved in the water. Now those particles aren't necessarily pollutants. They could be dirt from the surface of the ground that flowed in during a rainstorm. They can be broken down pieces of leaves and branches and things like that. There's also a very high nutrient content in water at the mouth of the river. The amount of oxygen dissolved in the water kind of depends on how much it tumbles and trickles over each other, because as water tumbles, it incorporates oxygen. Now remember, a lot of aquatic organisms need oxygen to survive. And usually at the end of the river, it is usually pretty wide. Now, a couple of terms about water around rivers. Land that's around a river's course that floods periodically is called floodplains. You can see in the picture below, we've got the river right here. So the floodplain is the area around it that occasionally floods. And when rivers flood, the sediment on the bottom of the river can get deposited on the land. Now that sediment has lots of nutrients in it. So this makes the land around rivers fertile. And that's why a lot of times farms are built around rivers because the soil is very fertile and it makes it easy to grow crops. Another area is called the riparian area. And riparian areas are riverside areas that are productive and species rich. They also drain into the surface water. So you can see above here, the riparian area is this area around the river. Okay, some other places that you find water on land are wetlands. Wetlands are areas in which the soil is saturated with water. So usually you've got shallow water with lots of vegetation. Now there are different types of wetlands, and one type is called a marsh. Marshes usually have shallow water with plants that grow above the surface. So this looks like a marsh over here. You can also have swamps. A swamp is when you have shallow water with trees growing in it, so it's forested. And swamps sometimes are created by beavers. On the other hand, bogs are ponds covered in thick floating mats of vegetation. And bogs can be a stage in aquatic succession. So you might remember from a prior chapter that succession is a predictable change in a community that leads eventually to a climax community. The climax community is the one that will not change unless there's some kind of disturbance. So for example, in New England on land, you might start with small grasses to brushes and plants, and then from there to saplings, and from there to maples and oaks, which are the climax community. Well, in water systems, you can also have succession, and bogs are a step in succession. Often bogs will fill in eventually and become land. That's not uncommon. So these are all wetlands, and wetlands are very valuable. Remember, we talked about this when we were talking about the Everglades. Wetlands are valuable because they are a habitat for wildlife. For example, in Louisiana, the coastal wetlands are homes to about 1.8 million migratory birds every year. Wetlands reduce flooding. Remember that in the Everglades, when they filled in the wetlands of the Everglades, there was no longer an area to absorb the excess water from hurricanes and rain, and so they had a lot of flooding in homes. Wetlands also recharge aquifers. That means they return water to the ground after it rains. They filter pollutants, and they're a place of photosynthesis. So people have drained wetlands, mostly for agriculture, for a long time. And unfortunately, at this point, southern Canada and the U.S. have lost more than 50% of their wetlands.